All right, so we've been looking a little bit at polynomials already. This section 3.4, it kind of just expands on that. And it says, well, what if I have kind of a complicated polynomial and I can't just factor it? How could I then find the zeros? So looking at something like this example, find all zeros and write in factored form. I have a polynomial here with a power 4. There's no way for me to just look at that and factor it. So I have to start breaking things down. I have to start with something. So here's a useful theorem. So what this theorem says is it says all rational zeros, so that's like all the ones that are either like integers or fractions, they're of the form P over Q, where P is a factor of the constant and Q is a factor of the lead coefficient. So what the heck does that mean? It sounds a little complicated, but it's really not. That just kind of narrows it down as far as, well, what might I try to see if it's a zero? Okay, so the possible zeros are fractions. Okay, let me read this one more time. P, that's the numerator, is a factor of the constant. This is the constant. So what are factors of 2? What are things that multiply to 2? Well, 2 or 1, right? But they could be positive or negative. So I could have positive or negative 2 or positive or negative 1. Q is a factor, so now I'm reading the next part. Okay, so Q is a factor of the lead coefficient. Okay, in this case, the lead coefficient is just 1. So this is an easy one. Okay, so looks like my only possible zeros for this guy are either positive negative 2 over positive or negative 1. So that would just be positive or negative 2. Or positive negative 1 over positive negative 1. That would either be positive or negative 1. So in this case, my possible zeros are just 2s or 1s, positives or negatives. So now I have to kind of guess and check to at least get one zero that works. So I have to take those possibilities and I have to plug them into the function. So I don't know. I can just pick something. Let me take like 1. It's an easy one. What is P of 1? I'd have 1 to the 4th, 2 times 1 minus 2 times 1 minus 3 times 1 plus 2. I'm looking to see if this is 0. Okay, so these are going to cancel. Oh, it is, isn't it? This is a nice one. 1 minus 3 is negative 2. Negative 2 plus 2 is 0. So then I would say, indeed, x equals 1 is a 0. Should I try another one? Let me see if negative 1 is also a 0. So what's P of negative 1? It's negative 1 to the 4th plus 2 times negative 1 cubed minus 2 times negative 1 squared minus 3 times negative 1 plus 2. 1 minus 2 minus 2 plus 3 plus 2. No, because it's going to be 3 minus 2 is 1. 1 plus 1 is 2. This does not equal 0. So x equals negative 1 is not a 0. Let me try 2. p of 2, 2 to the 4th, is it 16? Plus 2 times 2 cubed is 8, minus 2 times 4, minus 3 times 2, plus 2. So what is this? 32 minus 8 minus 6 plus 2, that's not 0. So x equals 2 is not a 0. Whew. So you've only got one more potential rational 0. Negative 2. Move this down. Can refer to it. Okay, so p of negative 2. Negative 2 to the 4th, 16. 2 times negative 8 minus 2 times 4 plus 6 plus 2. 16 minus 16, negative 8 plus 6. Oh, that one's 0. So x equals negative 2 is a 0. Whew. Okay. So then, what do I have? I have x equals negative 2 is a 0. And x equals 1 is a 0. So that means that when I take this polynomial and I factor it, I have to have factors x minus 1 and x plus 2, right? And then times something, okay? So the something here is going to have a power 2 because my leading term is x to the 4th. So what the heck do I do next? So let me go down here where I have more room. This is the next one. Move that out of the way. Okay, here's that polynomial again right here. Okay, and so again, what we were saying above is that for x equals 1 to be a 0, x minus 1 has to be a factor. For x equals negative 2 to be a 0, x plus 2 has to be a factor. But then what goes here? Well, what I have to do to figure that out is I have to divide both sides by this, right? And then I'm going to have that mystery quadratic that's left over. So the next thing I have to do is determine what that long division is. So I have to figure out what is x to the 4th plus 2x cubed minus 2x squared minus 3x plus 2 divided by, so this is what we did in the last section. So I'm going to write that out in expanded form. X squared plus x minus 2. Okay, how does this work? X to the 4th over x squared, got x to the 4th plus x cubed minus 2x squared. Subtract, get x cubed, and then I guess I get a cancellation. 0. Bring the rest of this down. And then I repeat. X cubed divided by x squared. So that's going to be plus x. Okay, so I get x cubed plus x squared minus 2x. Subtract. So minus x squared minus x plus 2. And repeat. Negative x squared divided by x squared, negative 1. Okay, and I'm going to apply that down. So get negative x squared, negative x plus 2. Okay, so I get a 0. So that would have to be true if we've done everything correctly. The remainder must be 0. Why is that? Well, because look. Otherwise, something's wrong. Because look back. Try to clean this up a little bit. Look back up here. This is what we're looking for, right? So what we're saying is that, I mean, this expression here is divisible by this expression because these two things are factors, right? So if I got a remainder that wasn't 0, it would mean that this numerator is not divisible by this denominator. So that would mean that these guys were not factors. We would have done something wrong. Okay, so luckily we got the 0. So then what the heck are we saying next? So let's see. We're saying that when we take this and divide by this, what we get is that quadratic. Okay, so how do I want to write that? Guess let me leave that there. And let me come back down here and say, okay, so what did we conclude? We concluded that our original polynomial make sure I copy everything down right. These ones are kind of long, huh? Okay, we concluded that when we divide out these two factors, the resulting quadratic looks like so. Okay. Now, let me see what the instructions said exactly. Find all zeros and write in factored form. So I see my two rational zeros, right? Those were 1 and negative 2. But this guy could contribute irrational zeros, right? In other words, ones that cannot be written as fractions. So the next question is, well, what about looking at this quadratic? So what about saying what happens if x squared plus x minus 1 is equal to 0? So it's not going to factor. What about the quadratic formula? X equals negative b plus minus the square root of b squared minus 4ac over 2a. See what that discriminant is. 1 plus 4. So I am going to have solutions. Okay, so what I have, let's see, I've got negative a half plus or minus root 5 over 2. All right, so I think there's only 2 of these ones, huh? These are long. So what the heck is my answer? So I guess I was asked, find all the zeros. So what were all the zeros of my polynomial? They were 1, negative 2, and then negative a half plus root 5 over 2, and negative a half minus root 5 over 2. So I have all 4 zeros of this 4th degree polynomial. The other question was, write the thing in fully factored form. So I have to finish that off, so let me see. My original polynomial, gonna need more room, so I'm gonna write the factored form here. So I had the x minus 1 and the x plus 2. But then I have to fill in my other 2 factors. These are gonna look a little ugly, but it's not hard. So let's see, what are my zeros? This one. So negative. Okay, so you see this factor gives me this 0. Okay, because I set it to 0 and then this guy is the 0. Then this one, negative 1 minus root 5 over 2. And that one corresponds with this guy. So then I have, that's the factored form. And then we get to go on. There's one more. At least this one's a 3rd degree. So that means I'm only looking for 3 potential zeros. So 3 factors at most instead of 4. All right. So the first thing I have to do is look for the possible zeros. So remember there, I'm looking at factors of the constant. So what are factors of 9? 9s, 1s, or 3s. Over factors of the lead coefficient. So factors of 3 are just 1s and 3s. Okay. So I guess my possible zeros would be 9s, 9 over 1. They could be 9 over 3. That would be 3s. Or they could be 1 over 1s, or 1s. They could be 1 over 3s. Those are thirds. And then the last possibility, they could be 3 over 1s. I got that already. Or 3 over 3s. Those are 1s. Whew. Got that already at least. So those are my possibilities. So what do I do next? I guess and check a 0. All right, so I don't want to work with 9s if I don't have to. I don't know, let me start with the easier ones. Let's start with the 1s. So what is P of 1? 3 plus 17 plus 21 minus 9. That's not going to be 0. Okay, what about, would negative 1 work? I don't think so, because my coefficients are too big. So let me try the thirds. Let's see about those. Let's try a third. It's 27. So what is that, a ninth? 17 ninths? Minus 2? 18? Oh, look at that. 18 ninths minus 2. That's 2 minus 2. That one works. That wasn't terrible then. So let's see. So I have 1, 0. So that means if I take my polynomial, that means when I'm breaking this down, if x equals a third is a 0, x minus a third is a factor. So then I have to figure out what is the quadratic thing that's here. Well, I guess, I'm going to have 3 in there somewhere. But I got to figure out what is this missing expression over here, call it like q of x. So what I have to do, same as before, I have to divide both sides by that x minus a third, and then I'll have this missing factor. Okay, so let me take that numerator. So that's what, 3x squared? Subtract. Bring everything down. Repeat. Multiply down. Subtract. Bring down. Repeat. Multiply down. And I better get a remainder of 0. If I've done everything correctly, which looks like I have, because again, this guy has to be a factor. So when I do this division, that remainder had better be 0. So now I know that missing factor, so I can say that that polynomial is x minus a third times that quotient. See, that whole thing's divisible by 3. So I'm kind of thinking, what if I factor that 3 out? 3 x squared plus 6x plus 9. Because then I could actually send that 3 inside that first factor. Oh, I think that one factors nicely, doesn't it? So isn't that x plus 3 times x plus 3? So look at that. So this polynomial in factored form looks like this. So I actually have a second power of 0 with a multiplicity of 2. So that's a nice one. Not terribly long. So here's the factored form. And so then what are the zeros? I have a cubic, so I've got 3 zeros. Well, 2 zeros, but one of them has a multiplicity of 2. Gives me my total degree of 3. Okay. So there are my answers to the question, but why don't we graph this one? Polynomials are really easy to graph. We've talked about that. So what are my zeros? A third. I'm just going to label that a negative 3. What's the end behavior? Like what power function resembles p of x on the ends? It'd be cubic, right? 2 plus 1, positive cubic. So down and up. Now what's the y-intercept? Well, if I plug 0 in the function, I'm going to get -9. Again, it's not to scale, I'm going to just label. Okay, let me look at the multiplicities. So at -3, we're going to touch, right? Because we have a power of 2. Touch. Here's my y-intercept. Let's see, what about at a third? Power is 1. So it crosses, right? Crosses through just like a line. Okay, so there you have it. So I have a graph of this polynomial function. So this section just gives you an extra tool, how to go about finding the zeros for more complicated polynomials.